Hi, this is Thomas Earl, and welcome to another episode of the Real Digital Transformation podcast series. Today, I'm very excited to have with me Johan Germishuys, the Director of Digital Solutions for Engineering Services Canada. Johan is here to speak with us about an incredible new project called the Canada Line Digital Twin. It uses a unique infrastructure, a unique approach to deploying sensors, and I'm very interested in getting into the details. But first of all, Johan, welcome, and tell us more about this project, please.
Hi, thank you very much, Thomas. It's nice to be here. So yeah, we're really excited about the Canada Line Digital Twin that we've been working on for the last couple of years. And really, it started a few years ago, about 3 years ago. And the idea when we approached our colleagues at Canada Line was to really understand some of the challenges that they had. Mostly one of the biggest challenges was taking desperate data that they had from various sources that they were receiving it from, either from telemetry or other forms of information, and trying to bring it all together. You are quite a busy person when you work in operations, especially considering it's a passenger rail line in Vancouver, servicing the larger metro area. So when we started talking to them, we really wanted to understand, what challenges they had. They were already quite an efficient metro line. They have a very high uptime or passenger service rate that they have. It's in the 98, 99%. So trying to find ways that they could improve that was, quite a challenge. But looking at some of the information or some of the data that they had, one key aspect that they had wanted to look at was something called swing time. For most rail or passenger rail lines in North America, the the asset that gives them the most challenges are switches. So you can imagine a switch is just moving a rail or sending a car from one track to the other track. Now those switches, operate quite a lot depending on how frequently that section of track is used. And they had quite a lot of data, but they didn't have a clean way of collecting it, collating it, and putting it together.
Mm-hmm.
So we went about identifying various stakeholders, how we could collect this data more efficiently, and how we could build a platform where it would start serving the purpose of a digital twin. And really, if you look at the definition of a digital twin, at least from my perspective, my simplest definition of digital twin is a data-driven digital representation of an asset. Okay.
Okay, so speaking of assets and a digital representation of that, I'll ask you a few more
Yep.
questions. And while I do that, I'm just going to share a couple of photos that were kindly provided to us for this. So here is the physical asset, I believe it's coming. Here's the physical asset that is being replicated as a digital twin. Here we go. So
Yes.
this is the actual line. This is the actual physical infrastructure. And we're going to show what the digital twin of this looks like shortly. But looking at this now, this looks quite comprehensive. If you go into the details of a track environment like this, there's physical components, there are mechanical components, and there's current running through them. There's technology along the track. How much, if we were to dive into this, how many different types of sensors? How did you approach this? The one thing about how this was created is that you didn't deploy sensors along the track. You had a different approach to collecting all of this infrastructure data
Yeah,
for
no
the
problem.
digital twin.
So
Please tell us more
one of
about
the
that.
first things that we wanted to do was, over and above just sensor information, we wanted to create a replica that somebody could physically or virtually walk into. And so we commissioned a contractor to come and do a full Lidar scan of the entire track alignment. Now, for those that don't know what LiDAR or point clouds are, um, you would take a track mounted scanner, and that scanner would shoot a light or laser against surfaces, and as it bounces back, it works like sonar, and it measures the exact distance down to within, tolerance of 2 to 8 millimeters across the entire track. And
Mm-hmm.
so we did that, worked on that, and we brought that into a virtual or digital environment. And that really solidified our baseline for what we wanted to do with our digital twin. So that was really one of the first steps that we went about, where we actually collected that LiDAR, and brought that into the environment. It enabled things like um, reducing risk for people to go and do a virtual or do a physical site visit. One of the most, we pride ourselves on being a very safe organization. We absolutely believe that safety is first. And one of the most hazardous activities that you can take on a rail operation is stepping on the guideway. So imagine somebody walking on the guideway at any point in time, trying to do an inspection, trying to understand how they're going to perform any kind of maintenance. That's a high risk activity for us. And in order to reduce that, using the digital twin and the scan itself, we were able to build a platform or an application where teams could go and visit the site or the guideway virtually without physically setting foot on it. So they could plan out activities weeks in advance, so that when they do get on the guideway, they spend the least amount of time possible on the guideway, and they can perform their work far more efficiently.
Mm-hmm. And so the data that was collected um, was used a certain type of approach to deploying sensors. And we had a quick discussion before this interview today, and you had drawn a distinction between a typical IoT solution that you may use to produce a digital twin and an approach that you had to use in order to do so for this track. Um, while you describe that, I'll switch over to the digital twin image that corresponds to this. Please tell us about how how you approached it, why it was not IoT per se, and the unique way in which you actually utilize sensors.
No problem. That's a great question. Um, if you were to break down the IoT, abbreviation, it's Internet of Things. Actually, I'll do what I did earlier, and I just grabbed one. So this is a IoT dev kit that Microsoft sells on their website. It's for people to use, to try IoT themselves. And IoT implies or infers that you need to have the internet to connect to it. So this sensor actually has a Wi-Fi chip on board, and it can connect to an internet line, or Wi-Fi hotspot. The Canada line itself is a 14-year-old asset. IoT did not exist back then. And the challenge with IoT itself is you need to have a Wi-Fi hotspot close enough to your sensor to be able to get information back from it. Um, Looking at Canada line itself being a track, you need to have Wi-Fi at certain intervals for you to be able to use IoT effectively. And it would also require us to retrofit the line, which in this case was not necessary. The SCADA system that's currently being used for all of the switches on the line itself already collects a huge amount of information. And what I said at the beginning, we wanted to take advantage of that information before we started looking for alternatives. So the Canada line operations themselves, they've collected a huge amount of IoT sensors over, no, not IoTs, sensor information over a certain period of time. They just needed to find out what were the triggers to predict when those switches were to fail. And that's
Mm-hmm.
where the digital twin really starts coming into its own. Digital twins being data driven, We want to take advantage of that sensor information to be able to train an analytics model that would understand what the triggers are for a switch to fail over time.
Hmm. So a typical IoT solution will have sensors deployed in different parts of a geography. They'll be equipped with wireless connections, and either in real time or during intervals will transmit that data back to a central collection point, and then it'll be sent back to the analytics engines. The difference here is that the sensors were mounted on like a little rail car
That's right.
that went all along the track. And so the reason it's technically not IoT is because you're not transmitting that data. The data was collected locally within the car. So it collected data, accumulated it while it went on a tour of the entire track, and then you took that data and brought it over to your analytics processing environment, and then did the reproduced the digital replica of it using that data. So I think you refer to that as vehicle mounted
That's
sensors.
right.
And so that approach allows you to capture this digital twin as it existed when the vehicle went along the tracks. Um, how do you keep the data current with that approach?
That's actually a great question. So looking at the LiDAR scan that we have on the screen, we've had quite a number of questions from the Counter Line team on how we keep that current. But you also have to think about the purpose of digital twins. They're really there to solve problems, or they're there to try and help you understand your asset better. Um, we would suggest that you do a scan like this incrementally as situations change on the track itself. So, for example, if you are doing significant construction or brownfield work, after that brownfield work has been completed, you'd want to go and do a new scan to understand what's happened to your track geometry. For example, one simple use case for that would be you had an elevated station. Um, a construction team would have gone in, they would have done some construction on the other side of that station. Now, do you know if the platform has moved or not? Well, you don't know that. It could be millimeters of change. So if you have a first scan and you take your second scan and come back and you can compare the exact geometry from one scan to the other scan, that'll give you indications of what's changed from point A to point B. So I don't think there's a hard and fast rule to anything. It's always going to depend on what's the question, what problem are you trying to solve, and how do you want to go about solving that problem.
Well, I think that this is a very practical way of actually realizing a digital twin, because having to deploy IoT sensors along an entire track and having them to establish the hotspots, and I mean that would make this type of solution, I would assume, much larger, much more expensive, much would take much longer to put in place, and would increase the cost of maintenance and governance as well. It would, given how long these tracks are, it would almost be unrealistic to do that. Having the vehicle mounted sensor approach, I think, brings this closer to reality much faster, and the data can be kept current as much as you wanted to. You could have it go, run along the track whenever you wanted to collect the latest version of the replica that you create. So real time data may not be necessary. So I think it's a very it's an ingenious way of applying sensor technology to produce a digital twin without necessarily having to invest in a full-blown IoT solution that's doing real-time data streaming.
I couldn't agree with you more, and it comes back to what you want to do in terms of your ROI. Right? You said simple, practical, straightforward. If we can demonstrate to our clients and the industry as a whole that they are very practical solutions that can give you that level of ROI, because I want to know what I'm going to get for what I'm going to invest into, right? And
Hmm.
what we did with the Counterline Digital Twin was really for us to demonstrate not just internally but externally our own expertise, but also how you can practically apply these in different situations. This is not the only example that we have, but it's the one that we're really proud of, and we want to showcase it. As you said, the simpler the solution, the more effective it is, the more people will understand it, the easier it is to buy into. And that's where you can really start that chain reaction to start looking at more. What else could you do with this? Another great example would be to use the point cloud to do other types of assessments or other types of analyses in the future. I want to see historically how my track is shifting around. We can start predicting how swing time impacts maintenance on the line as well. And then, looking at it moving forward, the advantage at the end of the day is to the end user, the passenger that's going to use the Canada line. The Canada line serves the airport and other metro areas within Vancouver. And if we can improve our availability to them and ensure that we maintain it as best as we possibly can, it'll make sure that every single passenger gets to the airport on time.
Hmm. Hmm. And while we've been talking, we've been actually showing the digital twin. So this is what it looks like, and it has, very impressive amount of detail. Can you tell us a bit more about what we are looking at? Do the colorations in what we see have any meaning?
I think that's a
Um,
great question.
yeah.
Okay. So the specific LiDAR laser scan was done a while ago. You can understand that the track itself is not available during the day. So the LiDAR scan is colorized, but ideally it's better to use it in black and white. Um, the reason for the color is because it was done during the evening, during off peak or outside of operational hours. Um, it's literally the track alignment as it goes across one of the bridges. The surrounding information is GIS information, and the level of accuracy, considering that the track is fairly long, the level of accuracy that you get with modern lidar scans is between 2 to 8 millimeters, which is pretty accurate considering this is a vehicle moving across the track for that larger distance. So any point that you measure on the point cloud or the laser scan itself is I wouldn't bargain on more than 8 to 10 millimeters on average.
And so if we looked at this same scan, the same photo, perhaps a year from now, uh, how would it look different? So the colorization would not indicate change
No,
necessarily. It would be more in the structural detail.
it would be more in the structural detail. Let's say something happened to one of the structures, or there's an expansion, or they add more track. The intention would be to really be able to take what you have today. Let's say I'm measuring a platform, for example, or there was an accident somewhere, and part of a pillar or column moved. You can go back to that historically, and you can do a really accurate measurement without physically having to go out to site. Or if a platform shifted, that you can go and measure the track center line to that platform, and understand those changes over time. This is also extremely useful for doing additional projects. So if there's a new line that's going to be added to Candleline, and they want to add new stations, instead of engineers or design companies going out to site to do measurements by hand, we can,
Hmm.
they can use that digital twin to be able to do those measurements without physically setting foot on it. And if they've got questions, I know I've been to a number of sites, and you think you've done enough measurements or dimensions. You take a tape, you measure, and you go, oh, I forgot something. I needed this measurement. So instead of having to switch the line down, go there during the evening, have eight hour or 2 days delay, you can use the digital twin immediately to go and re-measure that piece of section or track.
Yeah, it's amazing what this can do, and I would love to one day experience the going through a digital twin. You know, actually doing a tour of the digital twin to see how much you can zoom in and how much you can study and how much the sensors picked up. The sensors themselves, is it visual data only that they collect, or is there other types of data? Is there any auditory data or other types of environmental sensory data that they pick up when the vehicle goes along the track?
So for this specific purpose, no. It's mainly two pieces. It's the distance from the sensor to the object that it picks up, and then a picture. And that's how that's how it colorizes the point cloud itself. But talking about this is one facet of the digital twin that we've developed is the Lidar.
Mm-hmm.
But then there's also the analytics engine, which we don't have a picture of, but the analytics engine is also a real key driver in predicting, switch failure over time. And that's where we were using a lot of this switch related sense information to train our analytics model to be able to predict switch failure, or instead of going from a scheduled maintenance regime, which is very typical. If you think about any operation, we say we want to maintain an asset every 6 to 12 months. It really changed our approach to being more driven by our digital twin to say, I know this switch is going to fail in 3 months' time. So if I do more predictive maintenance on my asset, I can actually extend its life more.
So a switch on a track exists as a mechanical component, um, and it's not entirely. Are all of its mechanics exposed, or are some of them hidden?
Most of it's
Most of
hidden
it's
actually
hidden.
because of the elements. Yeah, most of it's hidden.
So the vehicle that drives by the switch and picks up the data from the switch, how does it pick up data regarding its mechanical competency? Yeah,
So the vehicle doesn't pick up that sensor information from the switches. That's hardwired.
in the switch.
Yep,
Okay, okay. So is that so the switch data, is that collected locally within the switch, or is that transmitted?
that's all transmitted, but it's not through IoT. It's hardwired, so it's a physical
Physical
connection
connection.
to
Okay.
a control system.
Okay. Oh, super. So along, let's say, a kilometer of track, how many switches would you typically have?
It depends. That's a really a depend question.
Okay.
So if I think about a bridge, you're not going to have too many switches on a bridge. But when you get into a switch yard, for example, or a maintenance yard, you'll have I can't say hundreds of switches, but you'll have a number of switches because you've got several tracks next to each other. And as you're bringing vehicles in for maintenance, you want to be able to guide them onto different tracks so that you can fill up the yard more efficiently. So it really depends. It's also think about some switches will have a higher duty. They'll have more activations than anything else, where some will have less activations. So
Okay.
it really depends.
Yeah, I can understand how critical that is. Having a dedicated physical line attached to them, I think, is wonderful because that gives
It
you
truly a critical infrastructure.
absolutely, yeah, absolutely. So the vehicle-mounted sensors, they capture the track infrastructure. You've got dedicated sensors hardwired into the switches. Are there other primary infrastructure components that have their own dedicated sensors, like the signals or?
Signals. I mean, there's numerous types of infrastructure, and you can imagine on a critical piece of infrastructure like Canada Line that most of them traditionally will be hardwired. That is the proven, tested way of operating these lines. And what I mentioned earlier, IoT is really it's not a new player, but it's a new player for different types of infrastructure that we're starting to look at and see come of age within the industry. But if you want something that's truly reliable, hardwire is by far the best way of doing it.
I can understand that absolutely. I have one question out of curiosity. So you mentioned that the Canada line for which you created the digital twin, when you put this in place, it was already over 10 years old. So that's your starting point for data collection, as opposed to perhaps a brand new line that would have the data collected right at its inception. So for when you start a project like this and produce a digital twin from infrastructure that is already somewhat aged, how do you determine what parts of the infrastructure may already have some flaws uh, without the benefit of historical data to reference that with?
So we have a process that we use called the digital twin framework. And as part of that digital twin framework, we have several steps that we go through. And the first step is called the discovery phase. And it's called that for a reason. We want to understand from our clients, the people that we serve and work with, what are their biggest pain points? What challenges do they have? Prior to even asking what type of sensor information they have, because let's say, for example, Canada Line had zero issues with switches. That would not have been the focus then. We
Mhm.
would have wanted to understand from them as a client, what types of challenges do they have? What's giving them issues during their operation? And based on that discovery phase, we really understand how we can help the client be able to address the issues that they experience. So whether it's a brownfield or a greenfield or an existing asset or one that we're just building, we really want to understand the challenges that they have for us to be able to address it most appropriately. And some of the most obvious ones might not be as obvious as we think they may be.
Yeah, it's really interesting because I can see this technology and this type of solution that you've built be applicable toward other types of urban environments. I not just limited to railroad tracks, but this could be very broadly utilized. And again, the practicality of it makes it something that makes it accessible to the community sooner than later and doesn't require a huge amount of financial commitment. I'm sure it's still substantial, but not compared to a real-time IoT solution. But so
100%.
yeah, and
So maybe as a couple of examples, right? As SNC, we really work across multiple industries, hospitals, bridges, road, rail, of course, in power, renewable power. And each industry's got its own opportunities and challenges, but we're absolutely looking at and working with numerous clients around the world to be able to see how we can address their digital twin requirements or needs.
and with all of the potential applications of this, within the scope of urban infrastructure, would your default approach typically be hardwired physical lines and not necessarily IoT? Does that kind of make sense as
I
yeah.
I think let's put it this way. I've been doing this long enough to know that any answer I'm going to give you today is not going to be the answer tomorrow.
Okay, fair enough.
And if I were considerate of that thought, then I would say today that might be the answer for a specific situation. In some cases, it might not be. So it will depend on the engineering. It will depend on the requirements from the client. We also have to consider things like cybersecurity. What makes the most sense in that environment? And as an organization, we've committed to building infrastructure responsibly, both from a net zero perspective and from a cyber perspective. So we take all of that into account to really provide the best solution that we possibly can with, what technology is available.
Understood. Um, so with this particular project, just to give us a sense of the scope of it, uh, if you add up the sensors mounted on the vehicle and the other sensors that are physically deployed throughout the track, how many sensors in total do you think are out there?
That's, that is a very difficult question to answer. The vehicle mounted one, I'm not even going to consider. That's less than a handful. Um, the number of switch assets in the field, I might have to get a better answer for you. I'm can't even quantify
Okay,
that answer.
no problem. I was just curious. Um,
No problem.
so, in terms of the data collected so far by your machine learning environment, for how long has this been in place? How much data have you collected? And have there been any revelations or discoveries that you can share from the data collected so far that may have been unknown prior?
That's a fantastic question. So the information's been collected for a number of years, even prior to us getting onto the project to talk about this, and consider a digital twin. And the best way that I can describe it, whenever anybody operates an asset, you start making assumptions on what makes an asset fail or not, or what makes it work well or not. I don't know if you've ever seen that meme where you hire a person and a, an entire ship stops working, and he takes a hammer and he looks around and he smacks one nut and the whole thing starts working. And you pay him an inordinate amount of money, and what that person has done is what most algorithms that we'll use to train will do. It will see things in data that we won't necessarily be able to pick up. And the operations team actually had revelations themselves as the machine started predicting the types of failures that they would experience. And it was not the indicators that they typically use to do that. So that it was definitely eye-opening for them to see the types of factors that really impacted the operation of a certain asset.
Okay, super. We're already over our allocated time. I know there's some video footage of this we wanted to share, but I didn't get to it today. I'm hoping to arrange a follow-up session with you sometime in the
Absolutely.
future to perhaps go into some more of the technical detail, and then we can share some of that. But I have one more question if you have time.
Absolutely.
Thank you. So beyond collecting the data to optimize maintenance, to improve safety, and overall better govern our city infrastructure, how much potential do you see in that data that's collected over time being further leveraged to improve how we build new city infrastructure? So if we were to build, if you've collected data from this line now for several years, and a new line needs to be built in this city or another city, using the same kind of trains and tracks, and but required for the expansion of urban infrastructure. Uh, how much benefit do you think that construction could gain from the insights, from the history, from the scope of data collected by having monitored this particular track using a digital twin over time?
That's a, again, fantastic question. And from my perspective, it's invaluable. Um, if there's one thing that we can say about human history is we try and learn and improve. I personally think that the last 20, 30 years has been a significant change in technology and how we apply it. And doing digital twins, taking advantage of that information, getting insights into how assets operate over time, by feeding that into these types of algorithms that can help us predict outcomes better. What we really want to achieve at the end of the day is more predictable outcomes. We want to understand when something's going to fail or how long it's going to work for. So, with our work within our organization, we are seeing the benefits across the world, because we're doing this not just in Canada, but we're doing it in every region, in the UK, in the US, and other countries. And we really want to pass those benefits on to our clients for how we, you know, take advantage of this information. At the same time, respecting that this is a client and they do have a unique way of operating their asset that's different to other clients. So it's always, a fine balance to make sure that we respect what we do for each and every one of our clients.
And I would assume that also those that construct the lines, those that construct even the train cars, perhaps there are improvements they could make to their technology resulting from the historical data you've collected. Maybe certain things are more prone to flaws that can be improved, so that what's built next time, the switch or other components, can be better designed in response to that.
Absolutely, yes. And that's where it's I believe in our industry being a relationship. When we start operating, it's not okay. I'm done. I've built it. I'm out of the door. Um, we look at those types of trains to understand and provide feedback to the manufacturers of these pieces of equipment to tell them, look, 6 years, that seems to have been the mean time before failure. Just as an arbitrary example, and then we can provide that feedback, and they can relook at their designs to really improve them. There's no perfect design, right? It's always a learning curve, so it's always something that we can keep on working on.
Super. Johan, this has been fascinating. Thank you so much for your time. I'm going to be bugging you for a follow-up session. But in the meantime, congratulations on the success of this project. It looks amazing, and I think it'll inspire much more adoption of this, and how this will help improve and evolve our urban infrastructure is really promising. So I've really enjoyed this. Thank you.
Thank you very much, Thomas. Thanks for having me.